Morning, seniors. Shop teacher chief here, pre-dawn hours. Got myself in early. Continue our chief talks about aluminum welding, inverters, transformers, welding technology, electricity, AC currents, and so forth. What I'd like to start out with this lesson is you have reactive metals such as titanium and stainless steel, and then you have non-reactive metals such as aluminum, steel, bronze, copper, so forth. So what I want you to think about is developing a solid baseline of knowledge and understanding of the difference between a transformer and an inverter technology. And when you go into the workforce, when you go into a shop, you have a good baseline of knowledge to set the machine up and to have the right tungsten selection, the right filler wire, the AWS classification of tungstens and electrodes and filler wires. But I'd like to sort of circle back again. I know we talked about this once before. Sometimes you get not a clear understanding. If you pick a wire up and it feels like it's aluminum and it might be stainless steel, there is an old technique that was taught many years ago to me. Take your fingers, and if you have a difficult time bending that wire is most likely stainless steel, which looks like aluminum. And if you have aluminum wire, you can actually bend it pretty well, okay? So that's just an approach or technique that I've used over the years, and I'd like to pass that along. As we continue on in aluminum, this will be your aluminum project that we'll do. We are gonna continue doing other fabrication projects with blueprints, but I'd like to begin with our base knowledge of high frequency, balance, penetration, and hertz. So we know that the electricity coming from the power plant, the electricity coming out of the wall is AC current. And if we're welding aluminum and magnesium, we're in an AC current mode, whether it's on a transformer or an inverter. But I'd like to continue to think about, as you're learning, perhaps you use your notebook. You've got sketching every day, our lessons, our technical information that the chief delivers in your QODs every morning. So please continue to develop your notebooks and making sketches and making notes. This will be an asset later on in your life as you go in and you become a welder, fabricator, sheet metal worker, whatever it might be. You always have a notebook in your toolbox, and you can always refer back to that notebook. So with that said, if you're looking at aluminum, so the aluminum, we've actually realized that aluminum is not as difficult to weld as we thought. But the fundamentals have never changed in a transformer and an inverter, and we'll talk about that. What I really need to talk about is the sine wave. The sine wave is the current of AC electricity. We know that we're on the top is positive for cleaning. We know on the bottom is negative for penetration. We know that straight line going across, when the sine comes up and down on a slope, the arc extinguishes, and that's what our high frequency allows us to continue. We know that we start out with sine wave, old school transformer technologies, which is still out there. You will still come in contact with those machines. That's why your program continues to keep those machines, but you will come across a square wave and then advanced square wave, which is behind me right here. So if we have an understanding, the sine wave, it has that sort of like undulating slope up and down on your currents from positive to negative. We know that we have advanced in our square wave technology. We'll talk about that as we progress. But I just want to make sure you understand there is the fundamental in aluminum welding and magnesium welding is AC, is the sine wave. Next is your high frequency. We know that the high frequency enables us to continue to weld when we're in aluminum and magnesium welding. We're in AC current. Because we know that when we go from positive to negative, when it crosses that line, the arc extinguishes. So the high frequency, which is built in an inverter, and it is sometimes you'll see on old machines, it's exterior on a transformer. It allows us to continue to do welding of aluminum. In a transformer mode, seniors, remember you need to be on continuous when you're in aluminum or magnesium welding. So when you're TIG welding everything else but aluminum and magnesium, you're in a start mode. So that would be the arc just needs to ignite itself in the start mode, but when you're in aluminum welding and magnesium, like we've talked about, it will extinguish every time it crosses from the positive to negative, and you need to have that that high frequency on. The next point of interest that we have is AC balance. The AC balance is the cleaning and the penetration. I'd like to just briefly talk about if you have a piece of aluminum that has come from the supply house and you've got relatively clean. We know that we use stainless steel wire brushes to clean our aluminum. We don't use a power wire brush to clean aluminum, but you don't need to have a lot of cleaning action because your aluminum is already clean. But if you have something that has been in the elements or been near salt water and has a heavy oxide layer on it, we know that aluminum melts at 1220 degrees. We know the aluminum oxides melt at 3,600 degrees. So 3 times the temperature increase to melt your aluminum oxide. But if you have a heavy oxide layer, you would have more on the cleaning and less on the penetration. So just make sure that when you approach a project or you're in industry and you come across something that's aluminum or magnesium that's very, very dirty, it's been in service for a long time, it may have heavy oxide layers on it, they need to be removed, but you can also use that in your cleaning mode. So back to AC balance, that's your positive as your cleaning, your negative as your penetration. As it slopes, undulates up and down, it goes back and forth from positive to negative. In an AC balance, back in the traditional days, and you might see these machines out there, they were 50-50. It was 50% on your positive, on your cleaning, 50% on your negative. So when I learned how to weld aluminum, that's what our machines were. We had no manipulation of balance at all. What you got was 50-50. However, on the Syncowave Miller, you can manipulate the balance and the penetration, but you still have 60 hertz, and we'll talk about that next. So remember, you can manipulate your balance and your hertz on your inverter enormously. You can moderately do that on a transformer. The old transformer, it was 50-50, and you couldn't manipulate or adjust at all. Next, I want to talk about hertz. Hertz is really, if you think about it and keeping things simple, is the profile of the arc. The balance is the cleaning and the penetration, and the hertz is the profile on how you can make that arc really wide and undulating, or you can make it very, very tight. And I'll talk about that in a minute in different types of joints. So the AC hertz is something very, very important. We can manipulate the time and the time on your balance and your penetration and the time in your arc. So balance and hertz are 2 different things, but are important things in your, obviously, your Syncowave. You can manipulate that a little bit, but in your inverter, you can manipulate that quite a bit. So remember, we're back to thinking about the difference between an inverter and a transformer and AC current and how you can change things up. So if you look behind me, first we start out in a Miller Dynasty. We start out, come down, drop it into AC mode right here on your left-hand side. all the way over to your right-hand side is your balance. So once again, if you've got good clean aluminum, don't need really a lot of cleaning action, right? If you have aluminum that has been in service and heavy oxide layer on it, you would need more cleaning. So the old school is 50-50. Unfortunately, Miller always gives you the negative on the indication. So for example, 50% would be on your penetration, 50% would be on your cleaning. If you are in doubt and you're learning and you're new to aluminum and magnesium welding and you're questioning yourself, I would like to give you some go-to numbers to start. And then from there, you need to explore and experiment and look at the arc and what it does with the cleaning action, that frost around the outside, the penetration, the arc itself. You can manipulate that. So if you're in doubt, start on, for balance, for cleaning, start on 60. That would be 60 on your penetration, 40 on your cleaning. And if you're gonna go into your balance, then drop down one to your frequency. Just start at 100. So 60 and 100, or 70 and 100, right in that range will get you going. However, I'm going to talk about how you can change your frequency in the different types of configuration of your joints. So if you have a joint that is wide open, you have a square groove butt joint, as they call it, you do not need to have a super tight arc. That is not necessary. So you can have a nice wide undulating arc when you're out in the open. If you are in a joint where you're in a T-joint, yes, now is the time you could take your hertz and you can sort of tighten up that arc. So you can go from 100 to 125 to 130 to 140. Miller sometimes recommends, a higher hertz for a T-joint. If you are in an outside corner joint, you would not need that super tight arc. You can use that wide undulating arc. So once again, seniors, it's early in the morning. I want to continue to talk, provide information, lessons to you, and get you well prepared for when you leave Assabet. You go into a fabrication shop or a job site, you come across these machines and technology, both old school technology and new school technology. You have a baseline of science and understanding of, number one, AWS classification in tungsten. Number two, AWS classification in filler wire, matching your filler wire as close as you can to your base material, knowing what your balance is on an inverter, what your balance is on a transformer, knowing penetration, balance, and your frequency, high frequency, to allow you to continue to weld for aluminum and magnesium. So once again, just to recap, if you're in aluminum and magnesium, first thing you're gonna go into is an AC current mode, whether it's on a transformer or whether it's on an inverter. Next, go all the way over and adjust your balance. If you're in doubt and you have very little knowledge and experience in aluminum and magnesium welding, 60 is on your, for a Dynasty, is on your penetration, so that means it's 40 on your cleaning action for your positive. Come down to your high frequency, drop into 100. So 100 could be your launch point. But remember, if you're in a T-joint, you need to get that arc tighter to reach down for your penetration in there. If you're on an outside corner joint, the arc can be wider, okay? So all these little snippets of information are good. Keep writing your notes, keep learning every day, keep showing up, keep trying your best, keep enhancing your knowledge and your skill sets, and we will best prepare you for what's beyond the stage at Assabet for graduation. We promise you that, and we will continue to have pre-dawn, early morning chief talks, and we just happen to be on aluminum welding and magnesium. So, okay, seniors, have a good, safe day out there. I will see you on the deck plate on Monday morning, and continue to do what you do. Bye now.